Hello everyone, welcome. This is your third chapter, Distributed Computing Paradigms. Here is the next paradigm, Remote Procedure Call Model or RPC. In this model, communication between two processes is carried out using the local procedure call concept. In a program that involves only one process, a call to a procedure such as a sum function, argument 1, argument 2 results in a detour of the execution flow to the code in the procedure. Arguments can be carried into the procedure as parameters for its execution. See, RPC is carried out using the local procedure call concept. See, the local procedure call involves only one process, a program in that only one process, a call to a procedure such as sum function with arguments, argument 1 and argument 2, it will deviate the program flow, okay, or execution flow to the code in the procedure. So arguments can be carried into the procedure as parameters. Okay, see here, this is how the local procedure call works. There is one program and function with the arguments 1 and 2. A function call is made here. This is a local procedure call. This is the program flow, but when a function is called, it will deviate the program flow. Okay, it will be deviate from the program flow, and function call is made. So this was the program flow, so it will change its flow to, it will jump to the function, and here the function is executed and it will carry out some task here and it will return the value, okay, return the result to the calling function. So this is how a local procedure call works. And a remote procedure call involves two independent processes which may reside on a separate machines. A process A wishing to make request to process B issues a procedure call to B, passing with the call a list of arguments. A remote procedure call triggers a predetermined action in a procedure provided by process B. At the completion of the procedure, process B returns a value to process A. See here, the remote procedure call, the difference between local procedure call and remote procedure call is local procedure call in a single machine in a one process, and here remote procedure call it may be on separate machines and two independent processes. See here, for example, process A and process B. Process A wishing to make a request to process B, so it issues a procedure call to B and it will pass a list of arguments. A that procedure call triggers a predetermined action in a process B. Okay, so there the procedure is executed, and on the completion of the procedure, process B returns a value to process A. So this is how the process B sends the response, and process A sends request and process B sends response in the form of remote procedure call. See the message passing paradigm, you know that message passing paradigm, here the messages are exchanged. So this message passing paradigm is data oriented, and RPC remote procedure call is action oriented, because when the procedure call is made, predetermined action will be triggered. See here, this is how the remote procedure call works. Process A and process B, process A on a separate machine and process B will be on other machine, and process A sends a request, so through a procedure call. A procedure call, that is procedure 1 and procedure 1 with arguments, argument 1 and argument 2. So process B, the procedure will trigger the action, some predetermined action here in the process B, okay, and it will process the task here, it will process the request and the procedure is executed here, and the return value will be sent to process A. Okay, so it will continue with the program with other statements. Okay, the program flow of was like this, and when a procedure call is made, the program will be flow will be changed. Okay, program flow will be changed, and after receiving the return value, it will continue with the other statements. So here the RPC model has been widely used in the network applications. Network applications like open network computing remote procedure call, open group distributed computing environment, that is DCE, simple object access protocol SOAP, all three are based on the RPC model or remote procedure call model. See here, next one is distributed objects paradigm. These are object oriented paradigms, and these applications access objects over a network. Okay, so the distributed objects paradigm are highly object oriented, and they provide high abstraction here. That means the program details are hidden here, and these applications based on these distributed objects are highly sophisticated, and objects provide methods through the invocation of which an application obtains access to services. So here object is provided and objects provide methods. So first the programs will access objects and objects will provide methods. So it will, through the invocation of methods, it can obtain the access to services. So here under this distributed object paradigms, we have a model that is remote method invocation model. So that is RMI. This RMI is object oriented equivalent of RPC. RMI is the same as RPC, but RMI is object oriented. In this model, process invokes the methods in an object which may reside on a remote host. Okay, so here arguments may be passed with the invocation and a value may be returned when the method call is completed. So it is same as RPC, but it is object oriented. Okay, there a procedure call was made, but here it invokes the methods in an object. Okay, and the methods will provide the services. See here, this is how the remote method invocation paradigm works. Process 1 and process 2, it makes a remote method invocation here, and a remote objects contain methods. Okay, objects contain methods. The process 1 will make a remote method invocation and it will access a remote object, and a remote object will provide methods. So these methods will be invoked to provide a required service. Okay, see here, next one is the object request broker paradigm. In this model, a process issues request to an object request broker, okay, to an object request broker or ORB, which directs the request to an appropriate object that provides the desired service. So here in this model, process issues a request to an ORB. Okay, the process issues request to an ORB or object request broker, and this ORB or object request broker directs the request to an appropriate object, and this object provides the desired service. So here in this model, object request broker functions as a middleware, okay, allowing an application to access multiple remote objects. So the request broker may also function as a mediator for heterogeneous objects, allowing interactions among objects implemented using different APIs or running on different platforms. So here request broker is a mediator, which so the requester will contact this request broker, and request broker will take this requester to the objects. Okay, the request broker will provide objects to the requester, and this request broker may also function as a mediator for heterogeneous objects. That means the objects implemented using different APIs or running on different platforms. Okay, objects may be implemented using any kind of APIs, or objects may be running on different platforms, but this request broker will access these objects. Okay, See, this is how the object request broker paradigm works. Object requester and object. Object requester contacts the object through object request broker. Okay, so this object request broker is a mediator between object requester and object. So object requester accesses this object through the object request broker. So object requester has to contact only this object request broker, but object request broker will access the object. Okay, so this paradigm is basis of the CORBA, common object request broker architecture. So this CORBA is based on this paradigm, and component based technologies like Microsoft COM and Java Bean, Enterprise Java Bean also based on distributed object paradigms. Okay, see, the next one is object space paradigm. The object space paradigm assumes that the existence of logical entities known as object spaces. Participants of an application converge in a common object space. A provider places objects as entities into an object space, and the requester who subscribed to the space may access the entities. So here logical entities known as object spaces. Okay, the participants of an application converge they gather in a common object space, and the provider places objects into object space. So these requester will have to subscribe to this object space, and the subscribers will have access to this object space. Okay, the object space paradigm provides a virtual space or meeting room among providers and requesters of network resources as objects. Okay, so here object in a space can be retrieved by only one participant at a time. So there are several requesters, so one requester can access the object in a space can be retrieved by only one participant or only one requester at a time. See, here this is the object space paradigm. This is the object space, and inside this object space there are several objects. Okay, so and requester will be there and provider. So this is a service provider and service requester. So these requesters and providers will have to subscribe to this object space or a virtual meeting room. So the provider will write information to the object, and the required information, the requester will access the required information. That means requester will read the information and the provider will write the information to this object. Okay.